Hello everyone, my name is Isis Almeida, and I want to present for you guys today a little bit about the article that I read. It's called Seafloor Mapping, the Challenge of a Truly Global Ocean Bathymetry. The authors are the ones exposed here in the first slide, and I'm going to talk a little bit about the context of the article, the history about the seafloor mapping, some perspectives, some limitations, and what has been going on right now and in the future. So to start out, we're going to talk a little bit about the four main objectives of the study presented by the authors. The first one being a review of the efforts made so far. The second one is a context of the history, so what has been done in the past, what kind of materials and instruments that they used to use to map the ocean floor. The third one is an overview of the current state of the seafloor mapping, with main focus in large-scale mapping tools. And the fourth one is to give some examples of the best practices in bathymetry, for example, like data compilation, archiving of source data, and other examples. So before we get in depth about the topic of discussion here, it's important to expose the method that was employed in this paper. So this is a bibliographical review article, so it synthesizes a lot about the topic itself, the bathymetry topic, and it shows an overview of seafloor mapping and compiles studies and works of different authors. So to start out, we can give a little context about the subject here in hand. So to this day, most of the seafloor remains unexplored by humans. There is even the possibility of there existing species that we don't even know about because we haven't explored all of it yet. People say that humans know more about the outer space than the ocean floor, and that's true because just a small part has been systematically mapped by direct observation, so there's still so much that we don't know about. And it's so important to know more about the ocean and more about this ecosystem, and because it can influence directly in important decisions, and it can help with managing plans for this environment that it's so important for us, and it can help us manage problems like climate change, for example, that is so present to this day. So here are some of the importance of having bathymetric data. So the first one is for navigation and establishing the limitations of the continental shelf. So that can influence in political and commercial aspects. For example, the EEZ areas that are the exclusive economic zones that refer directly to that. Something else is the management of geomarine hazard, as I said, like climate change, so the erosion of the corals and other problems that we face today that affect the well-being of this environment. It is really important to know to take better care. Predict ocean circulation events, for example, the El Nino or La Nina, that are dependent on the ocean circulation, and that can be predicted if we know more about it. Marine infrastructure installations, for example, cable laying, pipeline, and platforms that are required for industrial activities. Knowledge in case of tragedies, for example, when the Malaysia Airlines flight crashed into the ocean, it is needed information about the area, so they can send instruments under the water to search, and if you don't have information about that, how can you send an instrument? And the last one is the Agenda 2030 of the United Nations that has the life underwater goal for us to take better care of the ocean. So what has been done in the past about this topic? So there is evidence that water depth measurements were being made dated back to ancient Egypt. But the mark that started the ocean floor mapping was in the late 1800s with the HMS Challenger expedition. They just toured around the globe, and they used sounding poles and line with weights attached to them to map and to recover bathymetric data. So the need to search for underwater objects led to a development of the underwater acoustic techniques that just started the echo sounding era. So some examples that we can give about echo sounding instruments for mapping the ocean floor is the single beam echo sounders, the SBES, that are transducers that can generate and receive acoustic signals. When they were launched, it was a huge advancement in relation to early equipment used because they were far more accurate and efficient. Then the multi-beam echo sounders, or the MBES, they are a system that radiates signals in their perpendicular sectors. They are even better than the echo beam ones, the single beam ones, because they can map a swath of floor instead of just a line. And they work best in shallow waters than deep waters. Then we have the satellite-derived bathymetry, or SDB. They were developed in the 70s, and they can collect data in multiple spectral bands. They can be very effective and way less hazardous in collecting data of shallow waters than the MBES, because they don't have that much of an impact in the environment as the multi-beam one. Then we have the light detection and ranging, or LiDAR. They transmit laser pulses from an airborne platform and measures their return. They too are limited to shallow waters. And the last one we can talk about is the satellite altimetry derived digital terrain model, or DTM. They don't necessarily work with water depth, but they can measure the height of the water surface. So if there is like a seamount or a guillot in the bottom of the ocean, they can track that by measuring the height of the surface of the water. So what about the main data sources and repositories for bathymetric data? So the main data sources can be separated into three groups. So research cruises, normally done by governments and institutions across the globe. Then we have the national hydrographic offices. Normally each country has their own, that mostly map the EEZs, the economic exclusive zones that I talked about earlier, of each country. And the last one are the commercial surveys that are made to provide high resolution information and data to commercial customers. So where can we find this material, this data, this information? Is it available to the public? That's where the repository comes in. We can name a few here: the International Hydrographic Organization Data Center for Digital Bathymetry, or the IHO DCBD. They are a steward of the worldwide collection of bathymetric data. They are open to public discovery, and they are even available to download. Then we have the European Marine Observation and Data Network, or EMODNet Bathymetry, and they are regional and only for bathymetry of the European continent. The next one we have is the Global Multi-Resolution Topography, or the GMRT. They make elevation data products that are accessible for specialists and non-specialists. And the last one we have is the General Bathymetric Chart of the Oceans, or the GEBCO, that makes it available a wide range of bathymetric data like web map services, world maps, grids, and etc. So the first image that we see here is a print screen of the IHO DCBD bathymetry viewer that is displayed for the public to use, to explore, and to learn more about the bathymetry. The next one is a chart where we can find what I just talked about the data sources and the bathymetric repository. So the data coming from like surveys, fleets, industry, government, and going to different repositories, for example, the GMRT or the GEBCO, and some other examples shown in the picture. So moving on, we can talk a little bit about the perspectives and limitations. So a perspective for the future is implementing autonomous systems. They are multi-beam echo sounders that can be autonomous in its operations. That way you don't have to send crew members or some people inside the ships to manage the instruments. They can be remotely controlled or even autonomous. That can reduce costs and the risk of sending people in such a water depth that can cause various problems. And The next one is projects to make data public. So some governments and some commercial surveys don't share data for safety reasons and security reasons. So there is some movement around the globe to make this data available and acquire transit data. The next one is supporting crowdsourced bathymetry. So funding mariners, so civilians, people, to use professionally manned vessels to collect data and fill in the gaps that we don't have still about the ocean floor. And the next one we can talk about is the Seabed Project 2030. That is a initiative, a worldwide initiative, commanded by the United Nations to produce a map of the world's ocean floor by this date. Some of the limitations that we can pinpoint here, the first one being transferring of large data. So since they are such a high resolution data, is very difficult to share it and send it via internet, and then can be a problem to put it in the repositories. The next one, processing data, so turning raw data into high resolution data, demand like quality assurance, statistical filters to just ensure that the information is safe and accurate. Next one is convincing organizations to make data public. As I said, there are some organizations that are trying to convince, but as I said, some of them don't want to share because of security and commercial purposes, and it is really important to just get each data that we can have. So now to sum it up a little bit, talking about some recommendations that the authors proposed in the article. So there is a need of a collaboration across sectors. So it is obvious that mapping the world ocean floor is not a task that can be done by one institution or one government or one organization, global organization like United Nations. It has to be like a group effort. The next big thing is data transparency, as I said, to encourage the commitment to share data across the globe. And the next and the big thing is to map the gaps. So to fill in with new technology to map the places that we still don't have enough information about. So the conclusion here that we can share about this article, or the takeaway message, the take-home message, I put here: knowledge is power. So the more we get to know about the ocean floor, the more species we get to know, the more the habitat we get to know about the whole ocean environment, the better decisions that we can make on how to protect this place that we depend on so greatly, and that is so important for our daily lives, and it affects us directly. This can help us manage more efficiently and make better decisions about current challenges that we face. So the more we know, the better we can be for this environment. So that's my synthesis of the article. I hope you guys understood everything and that I was clear. Thank you so much.